In this video, we're going to build a sensor bracket to hold our infrared speed sensor. This will be used with the speed encoder disk that we built in a previous video. Once you've got FreeCAD open, begin by creating a new part. Make sure you're in the part design workbench and switch over to the tasks panel, create a body, create a sketch. We're going to do this on the XY plane. Once you're in the Sketcher workbench, begin by creating a rectangle. We are going right-click to clear your tool. We're going to constrain the length of the rectangle to 48 millimeters, and we will constrain the height of the rectangle to 43 millimeters. And then we're going to make this rectangle symmetric around the origin. So click on the top left vertex, click on the bottom right vertex, and then click on the center origin and use the constrain symmetric tool. As we can see, our sketch is fully constrained, so we can close the sketch. Pad the sketch out to 3 millimeters. And now we're going to create a new feature on the top of this block that we've created. So left click on the top face and create sketch. And our first feature that we're going to add is a pillar that we will use to hold the motor mount, or the motor. So create a rectangle, and we're going to constrain the top face length to 14 millimeters, and we will constrain its height to 3 millimeters. And we want to lock this rectangle against the edge of our block, so we're going to use the Create External Geometry tool, and we're going to reference the right-hand edge. Now that we've done that, let's click the top right vertex of our rectangle. Let's click the line that we just referenced, and we're going to use the Constrain Coincident tool to lock the rectangle to that line. Lastly, we are going to constrain the rectangle so that it is 19 millimeters from the top of our rectangle. So now that we've done that, our sketch is fully constrained and we can close our sketch. Let's pad this out to 27 millimeters. And we're going to now add a face we're going to add a feature to the front face of this pillar. So left click on the front face, make sure that it's highlighted, and then create a new sketch. And I'm going to zoom in here. I'm going to press the view section button, and that will make sure that none of the features of our model that are protruding towards us in the screen get in the way of the sketch that we're about to create. First, we're going to create a new rectangle, and we'll constrain it here in just a moment, but what we are going to do is we are going to reference the right-hand edge of our pillar, and we're going to constrain the bottom right vertex to the bottom vertex on the line here, and we're going to do the same to the top right vertex here to the top vertex on the line. So now our rectangle is fully constrained to the edge of our pillar. We're going to constrain the width of this rectangle to 9.4 millimeters. And our sketch is now fully constrained, so we can close out of it. And we're going to pad this new feature out to 3 millimeters. And we're going to come back in now, and we're going to add some holes in this pillar that we can use for bolting the motor to. So left click on the front face of this new feature that we just added and create a new sketch. And we're going to begin by just adding 2 circles. And we have to reference the right-hand edge of our pillar again. So I'm going to grab that Create External Geometry tool, reference that right-hand edge, right-click to clear my tool. And now I'm going to constrain these 2 circles by left-clicking on the center of both of them. You can see here on the left-hand edge, even though there's not a big color change between the blue and green, you can see that the 2 centers of our circles have been selected. And we're going to use this tool here to constrain them horizontally. So they are now linked together. If I move one, the other one will move. We're going to link the two sizes of these circles together. So I will select the outside shape of these circles, and then I will press the constrain equal symbol. So now if I increase the size of one circle, the other circle will increase in size as well. So let's constrain the diameter of this circle to 6 millimeters. This is going to be the size of the hex cap bolts that we're going to be using. We're using 3 millimeter bolts, and they've got a 6 millimeter head cap on them. And we're going to constrain the distance between these two circles. Again, left clicking on the center of both of them, we will constrain the distance between them to 18 millimeters. And now we need to lock these circles into the center of our pillar. So in our last step, we said that we set the width of this feature that we're working with to 9.4 millimeters. So we're going to center this by setting the distance from our referenced line using the constrain horizontal tool, and we'll set that to 4.7 millimeters. Let's bring that out so we can see that. So we're now linked to at 4.7 millimeters. And the last degree of freedom that we need to constrain is the distance of our top circle from the top of our pillar. And we're going to set that by clicking the center of the circle and again the top of the line that we created. And we will constrain that vertically to 4 millimeters. So now as you can see, we are fully constrained and we can close this sketch. We're going to create a pocket with these two shapes, and we will set the pocket depth to 3 millimeter. That is the thickness of this feature. And now we want to create through holes for the main shaft of the bolt so that we can actually attach the motor. And we'll do that by, again, clicking on the front face of this feature on our pillar. We'll create a new sketch. And now we need to reference a couple of edges here. So we need to reference the left-hand edge, and we will also need to reference the two circles that we previously created. Once you've done that, right-click to clear the tool. And we're going to grab the circle tool and make sure that you hover over top of the center of the circle and wait for the center of the circle to change a different color. Then left click and drag outwards, and do the same thing on the bottom circle. So now we have created two circles, and we're going to set them equal to each other. So you left click on the outside of each circle and click on the constrain equal tool. And we're going to constrain the diameter of this inner circle to 3.2 millimeters. And now we need to create a new circle on the left-hand edge here, and this is for a stabilizing post that pokes out from the side of these TT motors that we're using. And we're going to do this using some construction geometry. So the first thing that I'm going to do is I'm going to left click in the blank space here to make sure that I have no other lines selected. And I'm going to come up here to my shapes panel, and I'm going to toggle on the construction geometry. And you'll notice that when I do that, the lines connecting these red dots will go from white to blue. So left click on that. I now have blue lines connecting these red dots here. And I'm going to choose the Create Line tool. And I'm going to come up to my first circle, make sure I'm hovered right over the center and it changes color. Left click. And then I'm going to come down to my bottom circle, again hover over the center, left click. So now I have a construction line that joins the center of those two circles. I'm now going to create a perpendicular construction line, and I'm going to hover over top of this left-hand edge here and wait for it to turn a different color. Left click to start the line, and then I'm going to come over to this other construction line that we previously made, and I'm going to wait for it to change a different color, and then I'll left click. And it's really important that this line show that it is constrained horizontally. If your line wasn't constrained horizontally, let's say I'm just going to delete this constraint and show you what that would look like. So let's pretend that your line wasn't constrained horizontally. You would left click on the line and you would come up and you would constrain it horizontally, and that fixes that problem. Now, we have one major degree of freedom that we need to lock down here, and we want this construction line to be centered between the two circles. And it's as easy as left clicking on the center of the top circle, left clicking on the center of the bottom circle, and then left clicking on the vertex at the end of the line. And we can use the constrain equals tool, or constrain symmetric tool, sorry. And there we are. This construction line is now constrained in the middle between these two circles. Now I'm going to left click on a blank space to make sure that none of my lines are selected, and I'm going to come back up to my shapes panel here, and I'm going to toggle the construction geometry off, and I'm going to click on the create circle tool, and I'm going to hover over the end of this line that we just created, click on the center and drag it outwards, and I will constrain the diameter of this circle to 4.2 millimeters. The post on the TT motor is 4 millimeters, so 4.2 millimeters when it comes out of the 3D printer provides just a little bit of clearance around that post. Our shape is fully constrained, and so we can close this sketch. We're going to use these 3 circles now to create pockets all the way through this pillar. So click on the pocket tool, and since our pillar is 6 millimeters, we're going to set the length of our pocket to 6 millimeters, and that should clear the holes right through. Now that we've got that done, we are going to create the bracket that will hold the speed sensor. So left click on the top face of our base plate here, and we will create a sketch. And in the sketch here, we're going to create a rectangle. So drag this out, and we're going to constrain the width of this rectangle to 4 millimeters. And we will constrain the height of this rectangle to 32 millimeters. So now that we've done that, now we need to lock this rectangle in place. Now we could just lock this rectangle to the edge of our base plate, but if you wanted to integrate this into a larger base platform for the SparkBot robot, then this is kind of limiting you in terms of not understanding the relative positioning of this to the main motor mount. So we're going to reference the edge of the motor mount that we created here, and I'm going to do that. I'm going to use my reference tool, and I'm going to select this left-hand edge here. As you can see, it's partially hidden because the motor mount is extruding out towards us. So right-click to clear the tool, and then I'm going to come up here to View Section, and the motor mount itself is being cleared away, and we're just left with its base. So I'm going to constrain relative to this top left corner of the pedestal here. So I'm going to use the top right corner of our rectangle and the top left corner of our pedestal, and I will constrain them horizontally to 30 millimeters. You can see that that coincides with the edge of our base. And I'm going to select those same 2 points again, and this time I'm going to constrain it vertically to 8 millimeters. And this will give us the appropriate distance relationship between the sensor, the speed encoder, and the center shaft on our TT motor. So we can now close this sketch, and we're going to pad this new shape out to 17 millimeters. And now we need to add a couple of holes for bolts to hold the sensor onto our bracket here. So rotate around so that you're looking at the back face. Obviously, the back face is sort of an arbitrary designation here. Make sure it's selected by left-clicking on it, and create a sketch. We're going to create 2 holes, so create 2 circles. And we're going to constrain them onto the same horizontal plane. And we're going to make both circles the same diameter. So click on the ring for both of those and hit the constrain equal tool. And we're going to constrain the diameter of one of these circles to 3.2 millimeters. And we're going to set the distance between the 2 of them to 20 millimeters. Actually, let's make that 21 millimeters. So if you create a constraint and then you need to change it later, all you have to do is left click twice, double click on that, and you can set that and change it. So there, we've set that to 21 millimeters. And we need to constrain these circles on this back face. So we're going to constrain them relative to the top line on our bracket here. So bring in that top line, right click to clear your tool. Then we're going to zoom in and left click on the center of the left hand circle and left click on the left dot of your top line. And we are going to constrain it horizontally to 5.5 millimeters. And we're going to select those same 2 points again and then constrain it vertically to 3 millimeters. So now we have a fully constrained sketch and we're ready to close this. We need to use the pocket tool to create through holes here for our bolts. And the 5 millimeters easily clears our 4 millimeter post. So we'll just click OK. And our speed sensor has some pins on the back of the circuit board that protrude out past the edge of the circuit board. These are sort of the mounds created by the solder as they were used for soldering the main infrared sensor onto the board. So we need to clear away some of the plastic on the inside of this pedestal here, or this bracket, to make room for the pins that are protruding from the back of the circuit board. So select that inside face there, and we're going to create a new sketch. And as you can see, we have the main motor mount in the way. So again, we'll come up here and we'll view section. That clears that away for us. And let's create a rectangle. Make sure that when you're clicking to close that rectangle that you do not click on the main axis here. This would be the Z axis, because if you do, then your rectangle will be constrained to this axis line. All right, we're going to set the width of this rectangle to 13.5 millimeters, and we'll set the height of this rectangle to 7 millimeters. And we're going to lock this rectangle to the top of our bracket here. So I'm going to use the external geometry reference tool. There we are. We brought in that top line. I will left click on the top left corner of our rectangle, left click on our line, and then I will use our constrain coincident tool. The only thing left to do now is to constrain where this rectangle sits on that top line. So we're going to left click the two left corners here, and we will horizontally constrain it to a distance of 9 millimeters. Our sketch is fully constrained, so we'll close it. And now we'll use the pocket tool to create a pocket of 2.3 millimeters in depth. And that clears out the plastic on the back so that we can bolt the speed sensor flush with our bracket. Now, because this model that we've just created demonstrates the relative positioning of the motor mount with the speed sensor bracket, we're going to clear away some of this plastic so that when you 3D print it, we are just using less plastic. So left click on this left-hand edge here, and you will see that it's highlighted in green. Hold down Control key on your keyboard and left click the right-hand edge. So now, as you can see, we have two selected edges there. We're going to use the chamfer tool here, the fillet tool here. And we are going to create an 18 millimeter fillet. So that clears out a bunch of the plastic from the front. Not much, but it does save on a little bit of plastic. And we're going to select this back edge here. So left click on it, again up to the fillet tool. And we're going to give this one a fillet of 11 millimeters. And just because we can, we are going to select the left hand and right hand edges of the bracket that we just made, and we can fillet those, and we'll give them a fillet of 4 millimeters. So now we have the finished part that allows us to understand the relationship between the motor, the speed sensor, and the speed encoder disk.